Okay, circumference and arc length. So you should be familiar with circumference. You have a question? Okay, you're good. Circumference is the distance around a circle. It's like perimeter, but for a circle. Okay. So if we have our circumference here, I love it. My pen is on the fritz today. There we go. So our circumference is 2 pi times the diameter, or, sorry, not 2 pi, just pi times diameter, or 2 pi times the radius. That's our circumference. You need to memorize that formula. You should already know that from, I think, like 6th grade. You learn about circumference. You don't remember the circumference? Okay, and the area we'll learn tomorrow. Okay. The D is the diameter and the R is the radius. So if we want to find the distance all the way around a circle, so if I want to fence in a circular area, okay, I would need to find the circumference using one of my 2 formulas. So in this one, I said find the circumference of a circle with a diameter of 6 centimeters. We are not going to leave pi in our answer. We're going to actually multiply it out. So our circumference we're going to use, since I was given the diameter, is pi times diameter. So I find my circumference is pi times 6. Okay, you're going to need to find your pi button on your calculator. So everyone get your calculator out. Enter 6 pi. If you can't find your pi button, then ask your friend next to you. If together you can't find the pi button, then ask me. When I enter that into my calculator, I should get circumference is 18.84. Does the 4 make the 8 move up? No. Nope. So your circumference should be 18.4 centimeters. 0.8, I don't know why I just decided to change it. 0.8. Thank you. Whoever said that first here. Yes. It's 22/7. What?
It's not very different, but
that's interesting. It might have just rounded this number here.
Well, it rounded it here because then it had the full
yes.
extension.
So I don't know why they're slightly off there. Unless this is just a rounded number. So just use pi. Okay. So the next is the circumference. Find the circumference. Now they give you the radius of 7. So we're going to use the circumference equals 2 pi times the radius. So circumference is 2 pi times 7. So we have 14 pi. Let me plug that into our calculator. And I get 43.98. Does the 8 make the 9 move up? Yes. And if the 9 moves up, that means this 3 has to move up. So your circumference is going to be 44.0 and then inches. Any questions over that? Yes.
It has the radius. Can we just multiply the radius by 2 and use the diameter?
Correct. Yes. Which is what we're doing by the 2R, right? I'm showing all the work in our notes, though. So we know where it came from. Okay, the next one. In order to find the circumference of the circle, we need to know that this side is also the diameter. So again, the circumference should be pi times diameter, because I gave you the diameter in this case. So your circumference is going to be 12 pi. I got 37.69. The 9 makes the 6 move up. So C equals 37.7. And then this is just units. Well, they would give you like a centimeter or meters, but they didn't give it to you, so you just put units, whatever measure they're putting it in. Well, liters would be more of a liquid. Grams is a weight. All the way, walking around the circle, yes. Yes, full way, all the way across. Okay, back up here again. So find the radius of a circle if the circumference is 52. So now we're working backwards. They gave you the circumference. Of 52. So your circumference equals 52. So we're going to use our formula. Circumference equals 2 pi r, because they're asking you to find the radius. Okay, so we have 52 equals 2 pi r. Okay, you have to divide everything by 2 pi. This is having a hard time working right now. Divide everything by 2 pi. Okay, when you plug this into your calculator, you need to make sure you put parentheses on it. If you don't put the parentheses on it, you won't get the correct answer. Or I shouldn't say you won't. You most likely won't get the correct answer. Just depends on your calculator. And whether your calculator... You do 52 divided by the whole thing in parentheses, 2 pi.
Wait, what? Answer 8 point. I can't read that.
Sorry. You should divide it by 2 pi. In parentheses, though. So this is going to be, in your calculator, 52 divided by, in parentheses, 2 pi. And you should get your radius is 8.27. The 7 makes the 2 move up. And your radius is 8.3. And this is inches. Any questions on how we can get this answer? Anyone not able to come up with this answer on their calculator? We're good? Need some help? Okay, sometimes in like architecture or in gardening, you don't usually have a full circle. Okay, sometimes you're just gonna have a piece of a curve. Okay, so that's what we're dealing with now is arc length. When we just want part of the circle and how long that arc is. Okay, you'll see this if you have like a curved opening in a doorway. Okay, have you ever seen like a circular door at the top? Okay, you'll need to measure that arc to see how far you need, what length of a, I don't know how they make them because I'm not an architect or a construction person. What is it called? Oh my gosh. Contractor, thank you. That's what I was trying to come up with, or an engineer. Okay, but they might need a curved metal piece to make it, so they need to know how to cut that length. Okay, and this is how you come up with that length. Okay, if we remember back to similar figures, it's all about ratios. Okay, comparing different pieces to different pieces if they're similar. So this is how we deal with a circle. In a circle, we have two different types of measurements. We've already talked about one. The measure of an arc can be in a degree. Or we talked about saying it's a degree. But if I ever wanted to tell somebody, oh, I need a metal piece 60 degrees, nobody understands that, right? I'd have to tell them I need the metal piece to be 5 feet or 6 feet. Does that make sense? So I also need to learn how to find the arc in an actual length that makes sense to us. So if I compare the degrees to the lengths, I can do that. So here's your formula that you need to know. If I measure the central angle and I divide it by 360, that's like my ratio, my scale factor kind of a thing we deal with similar figures. That's going to be me comparing the arc length, this distance from here to here, to the whole circle, which is the circumference of 2 pi r. So those are my two ratios that I'm going to make a proportion out of. So in this, I'm going to use that formula. The central angle over 360 is going to equal the arc length over the circumference. So in this case, I have 124 is the central angle. It is always over the whole circle, which is 360 degrees. The arc length, that's what I'm looking for, the length of CD. Okay. And then it's over the circumference, which is 2 pi times our radius of 7. Okay. I'm going to simplify this piece first before I go any further. And so that's going to give me 124 over 360 is equal to x over 14 pi. We're going to cross multiply. So this times this and bring it down. And I'm just going to multiply the 14 times 124 and get 1,736 pi equals 360 times x, which is just 360x. I'm going to avoid multiplying by pi until the very end so I don't have to round a bunch of times. It'll make my answer more accurate. And accuracy is very important when you're measuring things, FYI. So we divide by 360, we divide by 360, and I get x equals 1,736 pi all over 360. I plug that exact thing into my calculator. And that gives me about 15.14. The 4 does not make the 1 move up, so the arc length is 15.1, and this is centimeters. Any questions over that? We're all good? Radian measure, we're not going to talk about right now. You eventually will learn about radian measure. It's just another way to measure angles. Okay. You'll deal with that in pre-cal and calc. Okay, so we're going to find the length of CD. So from here to here is what I want to know. Before I can find that length, though, I need the central angle. Any ideas on how I can find that central angle? Very good. This is a diameter. So the whole thing is 180. This piece is 120. So this is 180 minus 120, which is 60 degrees. So my central angle here is 60 degrees. We're going to use our same formula. The central angle divided by 360 is going to equal the arc length divided by the circumference. So I have my central angle of 60 degrees. Again, it's always over 360. And it equals, the arc length is what I'm looking for. That's my x. Over the circumference. Now, they didn't give me a radius in the picture, but they did say that AC, right here, is 10. So that's from here to here. AC is 10. So this is my diameter. So we're going to do pi times the diameter of 10. Any questions? Okay, so we're going to get cross multiply this times this and bring it down. That's going to give me 600 pi is going to equal 360 times x, which is 360x. Now what do we do? Very good. Divide by 360. Divide by 360. And I get x equals. Did anyone plug it into a calculator yet? 5.23. Does the 3 make the 2 move up? No. So x is going to equal 5.2, and again, centimeters. That's the length of that arc. Any questions over that? Okay, this next one we're asked to find the circumference. They gave you the arc length, and now we're just looking for a different piece of our proportion. So we're going to use that same formula. The angle over 360 is equal to the arc length divided by the circumference. Okay. So I have my angle, which is 60 degrees, divided by 360 is equal to the arc length, which I gave you to be 3.82. And I'm looking for the circumference, so that's my unknown on the bottom. Okay, come up with your answer for me, please. X ended up being 22.9. That's the answer. That's their circumference, and it was inches. Okay, now we're going to talk about track. Okay, the curves at the end of the track shown are 180-degree arcs of circles. Okay, the radius of this arc for a runner on the red path is 36.8. About how far does the runner travel to go once around the track? Round to the nearest tenth. Okay, so we're only looking at the red line. We're not worried about the blue outer line. Okay. They told us that these circles are half circles here. They're 180 degrees. Basically, the central angle is 180 degrees. Okay, if I have half of a circle and another half of a circle, together it makes what? A whole circle. Right? It's a whole circle. Okay, so if I want to find those two pieces, I can just put them together. And how am I going to find the outside? What's another word we have for the outside of a circle? Circumference. We're going to find the circumference of that whole circle. So your circumference is going to be 2 pi. They gave you that radius of 36.8. So I'm going to multiply that all together. And I got the circumference to equal 231.2. Okay, that's just the outside of the circles, right? Here and here. They want to know how far around the whole track it is. Okay, they gave me that this distance from here to here was 84.39. If this is 84.39, that makes from here to here also 84.39. This is 84.39. So if we add all the pieces together, the 231.2 for the curves, and then 84.39 plus 84.39, because you have to cover that on this side as well, you will get the whole thing. Yes? No, because we did the whole circle and put our two halves together. So there's not two of them, there's just one whole circle. If I did just half of the circle, then I'd have to multiply by 2. But I just added together. Okay, so this should be 400 meters, which makes sense. Does anyone run track? Right? Once around the track is 400 meters. Twice around the track is 800 meters. Okay. Shh. But that's on the inside track. Any questions over that? Okay, 9.4 homework is due